So this is the sketchy setup I've come up with to switch the bushes on the frame. This is a tube, it's a spacer from an old wheel somewhere. And there's a coarse 3/8 bolt through the middle, which is narrower than the bore. And we'll just push the new bush in and the old bush will come out the other side. That's the theory. Not going to film this, can't mount the camera here. Yeah, so that didn't work. I don't know if you can see that. Oh, battery's almost dead. So pushing out the old bushing with the new bushing, I got away with it on the two on the stirrups, but here on the frame it got stuck. Now I've bulged out that bearing and it's buggered. So on this side I actually tried to twist it off the old one and it broke, so that's a mess. So I'm now down one bearing. I'm going to have to make one. I have now made up this, which is made out of steel, and it's 10th thou undersize on the outside. It's got clearance on the inside, and I should be able to pull out the old one and then separately push in the new one. So I made myself up one from 932 bronze to replace the buggered oilite one from McMaster-Carr. So this is already reamed. Because with the hand reaming I wasn't sure I could necessarily do that in place, but it should crush up a little bit when it goes in and we can ream it again. It's at 1 thou oversize on the outside, 1 thou over ½ inch, assuming the inside hole there is ½ inch. So we'll clean up the hole and push it in, or just pushing it in with just pulling it in with a bolt. That's what we're doing. That worked out okay, so I moved on to making the bolts. I'm making these slightly different from standard. The later models had a machined in grease fitting on the end, just a pointy bit on the end for fitting a grease gun onto, so you could actually get some lubrication. The early type had no lubrication at all, and obviously adding lubrication is an improvement. I'm going to go one better here and make these with a pointed tip so that I have room to put in a screw-in modern style grease nipple with a little ball in it and stuff, because I don't trust me to use grease guns properly with the plain fitting that would come on the later type bolts. So we're doing a little bit more head. These bolts have a shoulder on them, which keeps the link plate bolts at the right distance from each other, so we don't have the clearance washers that we do on the larger bolts. And it's threaded with, I think it's a 5/16 cycle thread, 26 TPI. This is a 60-degree thread, like a unified thread is, so I'm using a generic unified pointy tool. Cycle thread is technically round top and bottom, like a Whitworth, but not a Whitworth, because Whitworth is 55 degrees. But this works out okay. And I've got the macro in the CNC to get the diameters for that quite well. So we did the shoulder section first, and now we're doing the length here. So the length between the head and the shoulder is a critical dimension, as it keeps the two link plate bolts separated. And the link plate bolts one of the bolts has a larger diameter holes in it than the other, so one of these diameters goes through one link plate bolt and the other one goes through the other, and then they get tightened up, and the side-to-side play is controlled by this length here. So I've got a good finish on this. This is 12L14, which is easy to machine. It's probably not the hardest and most durable material we could use here, but for this purpose it's probably going to be fine. Again, I don't expect this machine to ever do a lot of miles ever again, so as long as we get it serviceable, it should be fine. And if things wear out, I can always make more. So that explains the very long head on this, is that we have to carve this down now so we have enough metal to screw in a grease nipple when we're done. So I flipped it around and I have it in the lathe with some protective shimming from a Coke can, and putting in a bit of a taper here so that we have the right size at the top for the BSF grease nipple, and then enough space to make a standard size hex at the bottom of that. And we put in our grease way. So we start off with a center drill, and then we drill the necessary distance into the part to make the oil way, or grease way, I should say. And pecking this so that it doesn't break the drill and stuff, and keep it clean, because it's a very, very deep hole for this size of drill. And you keep the speed up, do short pecks, clean off the chips, keep it lubricated, and it works pretty good. And each of these operations I'm doing 4 times because there are 4 of these bolts. And we come in with a tapping drill size 4, I think it's quarter BSF. And the grease nipples themselves from McMaster-Carr, they're extremely cheap. They sell them in boxes of 50 or something, and you get a lot of them, so I'm never going to run out now. Clean out the hole, and the grease nipple fits. So it doesn't look standard, it is significantly longer than standard, but maintenance is important, and it's not going to collide with anything. And I use my new Spindexer to make some hexes. This isn't the first one that I did, so I already have all the dimensions set up for getting the hexes to the right depth. And it's just a case of going around and doing the 6 sides, and you get this nice effect with the conical shape going into the hexagon. And this fits a quarter Whitworth spanner. These are not the greatest Whitworth spanners, so they are a bit loose. The dimensions on the hexes are correct. And we have to do the cross hole for to let the grease into the part. Sorry about the wobble here. Still working on my camera mounts. And blow it out, give it a clean, and that's the final part. These I am happy with. I'm very happy with these. They're dimensionally to spec, and they have the lubrication on them, and they're all shiny. So I'm tempted now to get things polished and plated because things are getting shiny. So see you next time.